So in this problem, we have a person writing a test. They have two questions, and one question is true, false, and the other one is a multiple choice with 5 options. Okay, so they're completely guessing at the true, false question and the multiple choice question. So what's the probability that they both get? They get them both correct. So it says draw a tree diagram for the sample space. So we can draw a tree diagram like this. We have true and false. And for the true, there's 5 options: A, B, C, D, and E. And for the false, there's 5 options: A, B, C, D, and E. So assuming that there's only one correct answer, okay, we can say that they got, let's say that the false question was correct and C was correct. So there's only one outcome that is going to be getting them both correct. So probability of both correct is going to be, there's one option and there's 10 possibilities. So the probability is 1 out of 10. Okay, so this is a tree diagram. Really, since this is a 2-event probability, this one actually would be much nicer with a grid diagram. So having true and false. Okay, and then we have our multiple choice being A, B, C, D, E. Okay, and we'll get the same result, but it looks kind of nicer. I think it looks nicer with a grid diagram. Okay, so our question that is both questions correct is just that one there. Okay, we just kind of arbitrarily said it was false and C was correct. So 1 out of the sample space, shows 10 options in the sample space. Okay, so what's the probability of guessing the true, false question correctly? Well, that's 50%, so 1 out of 2. What's the probability of guessing the multiple choice question correctly? Well, there's 1 correct answer out of 5 possibilities, so 1 out of 5. So guessing them both correctly is going to be 1 out of 10. Okay, we can see in our tree diagram and in our grid diagram that's true. Okay, so that's going to be 1 out of 10. And we can see also that if we actually multiply these probabilities together, so probability of true correct and multiple choice correct, okay, is going to be the probability of the true times, since these are independent events, okay, they're consecutive independent events, we can say that the probability of true times the probability of multiple choice, true false, let's say go true false, and multiple choice correct is going to be 1 out of 2 times 1 out of 5, which gives us the 1 out of 10 that we see in our diagram. Again, the sample space is going to be the most reliable, but this is a nice efficient way to get the probability. Okay, and we can do this when we have consecutive events, and the probability of each event is independent. Okay, so we can take a look at this next one here. So you have 5 students. They're going to be chosen on a dial, okay, on a spinner. So the probability of choosing any one person is 1 out of 5. And the game board is divided into 6 sections. So there's 6 different prizes. Okay, and so the student is selected by the spinner, and then we roll a dice to see who wins that prize. So what does the sample space look like? Okay, well, let's make a sample. So this again is a 2-event, selecting the person, selecting the prize. Okay, so I'm going to make a table here. So we're going to say Anna, Ella, Bob, Colin. Well, actually, let's just do this in order. Anna, Bob, Colin, Dave, and Ella. Okay, so those are the people options. We also have the prize options. I'm just going to do the prizes as 1, 2, 3, 4, 5, and 6. Okay, so our sample space, there are 30 elements in our sample space here. Okay, so our grid is, we have 30 elements in our sample space. And it says here, how likely is it that Anna or Dave gets a Slurpee or a free lunch? Now the or is really tough. Okay, we can't be multiplying with ors. So if we want to look at Anna or Dave, we're looking at these two columns here, Anna or Dave, and we want to get the prize. The prize is a Slurpee or free lunch. Okay, Slurpee. So Slurpee was number 1. Okay, oh, that one does not overlap, so let's choose a different color.